This graph is going to introduce our first, this video will introduce our first graph in this class, and it's the production possibilities frontier. It's a very powerful graph, and it can illustrate some very important concepts or definitions in economics. I'll have a second video where we'll actually use the production possibilities frontier to talk about feasibility and efficiency. But first, we're going to have this video just to introduce the graph. So what we're going to do here is we're going to attempt to graphically illustrate the options for production, because that's what the in effect that the label or the name for this graph shows is production possibilities. We're going to show the different options that we have, possibilities for production that we have in a simple economy. Well, a simple economy, we're going to assume that there are two goods in this economy, but the goods have to be produced. We obviously there's thousands and thousands of goods in a real economy. We're going to just simplify here and assume we have two. Why is that? Well, because two dimensions are what you can actually show on graphs. So this will be one of many different cases where we'll simplify things a lot simply so that we can draw a graph. That we're going to draw a graph that you can recognize and try to make sense of, as opposed to some kind of complicated multi-dimensional space. So in reality, a production possibilities frontier would have to have thousands of dimensions, but who knows what that is. Let's imagine that there's a very simple economy where we have two things that have to be produced, but these are goods and they have to be produced. One of the things about production is that we have to use resources. So when we're going to draw a production possibilities frontier, there are three things that we're going to imagine that we're holding fixed in our economy. And that is, first off, the resources. Resources, economists refer to resources as they're the things that we would use, the ingredients that we would use in production, the things that we need to have in production to be able to produce goods or services. Technology refers to our ability to convert those goods and services into, or those inputs into the goods and services that we want to consume. So technology would mean, how much output do we get for a given amount of input? And if you think about over time, we have to think about agricultural economy. Thousands of years ago, humans were out there, planting seeds with, then we were pushing a plow or trying to dig the dirt, maybe with some simple shovels or whatever. If we compare with what we do now with combines that they go through and plow up the ground and then plant the seeds, what's happening is we have a lot better technology. But we're going to assume that we're going to hold technology constant. And then the third thing that's going to be involved here is institutions. Institutions are refer to things like forms of business organizations, things like ability to borrow or lend money for, in others, get capital or investment capital into businesses. And so those will be important as well. But we're going to hold all of those things fixed here. And assume that we have a simple economy where we have two goods. I've picked corn and oranges because I think this will, for one example, sort of makes sense as we talk through to illustrate a little about the shape of this curve. So what we can imagine now is well, you need to have land, you need to have labor, you need to have seeds, maybe some other things like fertilizer, water to water crops. So those are our inputs, but we're going to have a fixed amount of that. So we have a fixed amount of labor and a fixed amount of land, and then a fixed amount of these other inputs. So let's see, oranges, we grow oranges in Florida, corn, grow a lot of corn in Iowa. So we have the land in the states of Iowa and Florida. And we're going to attempt to grow corn and oranges. Now, to construct this graph, what we want to do is do a couple of hypotheticals here. We could start and say, suppose we take all of our available resources and put them into growing corn, and not to put no resources into growing oranges. And imagine how much corn you could produce. Okay, so there would be a number, and if we really wanted to do this to mimic the U.S. economy, we'd have to try to estimate what that number is. But this is a made-up economy here, so whatever that number is, let's just say, okay, here it is, and here's some number here, and the exact size of that number doesn't really matter, but it's a given amount of corn, And given what we said in terms of the how we got about getting this amount of corn, we said we're putting all of the resources into growing corn, no resources into growing oranges. So therefore, we don't have any oranges. So we have to have 0 oranges and as much corn as possible. And this is going to be the maximum amount of corn that can be produced in our economy. That will give us 1 point on the production possibilities frontier. Then we can come down to the flip side of that hypothetical. Say, suppose we put all of our resources into growing oranges and no resources into growing corn. Well, since we're not putting any resources into growing corn, we're planting orange trees everywhere, the quantity of corn that we'll have is 0. And then we'll be able to grow a given number of bushels of oranges. How many? Who knows? But again, it doesn't really matter what the exact total is. There'll be some number here, and we'll plant and we'll graph that number, whatever it happens to be on the x-axis. And it's going to be on the x-axis because we said you can't have any corn when you put all the resources into growing oranges. So we have 2 points on the production possibilities frontier. Now, anytime we introduce a new graph, there are a few things we're going to want to talk about. First off, what's going to be its shape? And is it going to be positively or negatively sloped? Is there a reason? And is there an economic reason a curve has to be positively or negatively sloped? Another question would be, well, what's the exact shape of it? Is there any economic meaning when we come down to thinking about the shape of it? Is it linear or is it going to be bowed? And then a third thing we're going to ask is, well, is there an economic meaning that we can apply to the slope? Remember, the slope of any curves, the rise over the run. And so is there an economic meaning to the slope? And for our production possibilities frontier here, it turns out the slope does have an economic meaning. Because if we think about it here in our economy, we put all of our resources into producing corn, and this is the amount of corn we could produce. And of course, we got no oranges. And then we put all of our available resources, given the technology we have into producing oranges, we could have this much oranges, and of course, no corn. Well, when we, in this economy, remember in chapter 1, we introduced the definition of opportunity cost. Opportunity cost is the value of the next best alternative foregone. In a too-good economy, when we produce oranges, the opportunity cost of the oranges would be the corn that we don't get to produce. So when we think about comparing these 2 points here, all corn, no oranges, all oranges, no corn, if we wanted to switch from having corn to having oranges, we'd see is we would give up the corn and we'd get oranges in return. Giving up the amount of corn that we give up, that's the rise, and then the amount of corn that we get would be the run, if so you think about slope. But that's also exactly the opportunity cost. The opportunity cost is when we produce oranges, what we've done is given up the opportunity to produce corn instead. So the slope of the production possibilities frontier is the opportunity cost of producing the good that we have on the axis. So the opportunity cost of producing oranges. We live in a world of scarcity. And because of scarcity, we have a fixed amount of resources. So when we take resources out of the production of corn, it must be the case we will be able to produce less corn than we could have before. So that we live in a world of scarcity says that if we're going to go from having all corn and no oranges to producing oranges, we have to give up corn. Scarcity says that the opportunity, we were going to have an opportunity cost there. So scarcity is telling us that this production possibilities frontier has to have a negative slope, and the negative slope reflects this opportunity cost, that when we want to produce more oranges, so we're going to have a positive run, an increase on the x-axis, the only way we can do that is give up some corn, so we're going to have a negative number, or we're going to have a fall on the y-axis, so that's going to be a negative rise over a positive run. That's always going to be a negative number. So the slope of the PPF is showing us the opportunity cost, and this curve has to have a negative slope. Now, the only question is the production possibilities frontier could be linear or bowed? And it could, in theory, be either one. Depending on the exact nature of technology, it could be either one. But probably generally, we're going to draw the production possibilities frontier to be bold. And the reason for that is, well, remember, the slope is telling us the opportunity cost. And when we draw it to be bold, what that means is that the opportunity cost is changing. So when we draw this to be curved here in this fashion, what we're assuming is that we have increasing opportunity cost. We're assuming that we live in a world with increasing opportunity costs. Now, why is that? Well, it sort of makes sense. And the reason why we think we live in a world of increasing opportunity costs is that resources are specialized. In particular, if you think we have Iowa and Florida as two states where some of the land is in Iowa, some of the land is in Florida. Well, the land in Iowa is really good for growing corn. Land in Florida is really good for growing oranges. It's going to be pretty hard to grow oranges in Iowa because, well, it gets really cold there and those orange trees would freeze and be damaged. So it turns out, so if we want to think about it, if we're going to start producing oranges, what would make sense is that, okay, we'll grow oranges in Florida. And so when we grow oranges in Florida, we'll get a lot of oranges for the amount of land in Florida. And if we use the land in Iowa to grow corn first, well, since the land there is so good, we'll get a lot of, when we grow oranges when we grow corn in Iowa, we'll get a lot of corn with that. So what that means is that we have a point out here in the PPF where we sort of think, this point here could be saying we're going to grow all the oranges in Florida, we're going to grow corn in Iowa. And the thing is that if we try to grow oranges in Iowa, we realize, well, we wouldn't get very many more oranges, especially very few oranges compared to the amount of oranges that we got in Florida. And if we try to grow corn in Florida, we won't get that much extra corn out of Florida, not nearly as much as we're getting per acre in Iowa. So that means that, this is really sort of the opportunity cost of switching from growing corn in Iowa to growing oranges in Iowa. We want to draw, this is the, I'm sorry, that was backwards. This would be switching from putting Florida onto corn to putting Florida on oranges. So we would get all those oranges we grow in Florida and we'd lose relatively a small amount of corn. This would be the effect of switching from growing corn in Iowa to growing oranges in Iowa. We would lose a lot of corn and get very little in the amount of oranges. So when we think of the opportunity cost, rise over run, the rise here is going to be small compared to the run because we get all those oranges out of growing oranges in Florida. Here, the run has to be smaller because that's the amount of oranges we're going to get out of Iowa, and that's going to be very small. In fact, it could be tiny, tiny. And this is all the corn we give up when we plant corn in Iowa. So the slope of this, it makes sense that the slope is going to be getting steeper. The slope of this curve would be getting steeper. And that would mean it's not going to be linear because the slope's going to change and the slope is getting steeper. And in this regard, we'd say we face an increasing opportunity cost of producing oranges. If we're already producing most of our oranges and we've been smart enough to grow oranges in Florida first, then that means when we try to get this last amount of oranges, we're going to be using resources that would be really good for other things and not very good at growing oranges. So, we're trying to grow oranges in Iowa, and that's not going to be very successful, and we're not going to get very many extra oranges out of that. And that means that we would give up a lot of corn for a very little amount of oranges. That means that opportunity cost, the slope, has to be very high. It would be a big number. So we usually draw the PPF to be bold in this fashion. Depending on the technology and the type of resources, if you don't have specialized resources, then the production possibilities frontier could, in theory, be linear. We have some simple numerical examples to illustrate in the book where we're going to have a linear PPF. But in most cases in the real world, since we believe we have specialized resources and we have this, and we live in a world of increasing opportunity costs, we're generally going to draw this PPF to have a bowed shape to it. So it's going to have a negative slope. It could be linear, but most likely be bowed. And the slope of this curve is the opportunity cost of producing the good on the x-axis. So that's our first curve, our first graph in this class, the production possibilities frontier.